Hello guys and welcome to my channel again. New delivery today. We are dealing with the KORAD KA3010P USB programmable power supply, 30 volts, 10 amps. Technically, you are supposed to connect this power supply to your laptop. So let's see how it works. This thing is really heavy. So it's a linear power supply. Technically, it is supposed to have like a large transformer inside. So, large LED display, some buttons, outputs, rotary encoder. In the back, 220-110 input, AC input, serial port, USB port, USB type B port. Okay, let's see what else is in the package. USB cable, output leads, input cord, user manual, DVD, bill, and electrical performance test. And this is like a certificate. It says pass here. That's really interesting. It's like I'm buying something like this and I expect to find something failed here, or how is this proving that this device is better than I expected? Anyways, we're gonna put the software DVD inside here. Power cord. Oh, see, these leads are exactly the right thickness, so you can feel them. They have a lot of copper inside. I think it's at least 2 square millimeters or so, by the way they keep their shape when you bend them. Standard 4mm connectors, clip leads on the other end. So this is probably what you would have to expect in every power supply, so this is a really good thing. The possibility of having the minus connected to earth or to the minus of the power supply. And let's see how it's powering up. Oh. So you get this buzzing sound mostly every time you're powering it up. The kind of sound that you hear in things that are magnetizing. Probably the internal transformer is making this sound. Sometimes it's scary, sometimes it's annoying. I don't know why the case is vibrating like this, but anyways. So the manual control panel has these buttons right here. You are supposed to have 4 memory locations that you can select from. So suppose you're selecting this memory location and then you're pressing the voltage current button. You are prompted with some blinking digits here, and wherever you see the blinking digit you can go ahead and use the rotary encoder to actually modify the value here. Now you can also use these left and right arrows to select between the digits, and then you can go ahead and rotate the knob of the rotary encoder just to modify these values right here. And once these values are set and you don't touch the control panel for like 3 seconds or so, the numbers here stop blinking, and this is a sign that everything was already stored to that specific memory location. Now if I'm coming back to M1, I will see the previously set values. Nothing really complicated so far. You have the this upper right button right here. It's the lock button. If you press the lock button, then these other buttons on the control panel won't do anything unless you unlock it, and then you can go ahead and operate it manually. So sometimes I find this button really helpful if you are conducting some test or something, or if you are leaving the power supply out there on the shelf in your shop, and you have something powered there and you don't want anybody to interfere with your things there. It's good to have a lock button. Okay, then you have some overcurrent protection button. If you press it, some LED here on the screen will light up, and you have some over voltage protection function, and this on off button right here in the bottom right section will actually enable the output. So I actually have power here. Now if I set this overcurrent protection function and the current actually exceeds this set value, this will disable the output, and I will have actually no power here on the output. The same thing is with over voltage protection. If I'm having some, I don't know, inductive device here technically, or some device that will generate some small amount of voltage, some millivolts back into the power supply, and this over voltage protection function will notice some increased levels in the output voltage, will disconnect everything down. So this is pretty much how the manual panel is operated. Now let's see if it connects to the computer. I took the liberty, as always, of installing the software beforehand, so we save on time. Technically, you are prompted with a small window like this, if you are able to see it well. Yep, here you go. And you have the possibility of selecting between multiple ports here. Technically, if you installed everything correctly, you will be able to see COM3 or other COM port here that you weren't seeing before connecting the USB cable. So let's go ahead and select this, and you have an enter button right here on the right. If you press that, we are prompted with this control panel right here, and this control panel right here has the possibility of interfacing with the power supply. If I'm modifying the value of the voltage here from the voltage knob, this will automatically modify the voltage on the screen of the power supply here, and if I'm adjusting the value of the current from this other knob right here, this will lead into some modified value here on the screen. And of course I have the same buttons here, the overcurrent protection function, the over voltage protection function, which I can select from these buttons on the screen, and I have the on button right here, which will actually activate the output of the power supply. The most interesting part of all is this right section right here. It's like a chart of values, and you can select some steps, and this program basically will run these steps over and over again, or how many times you choose to have them, and you can basically create some pulses here, or you can have some voltage steps, and each individual voltage step can be assigned a specific length of time, and you can also assign some specific maximum current for each individual step. So let's go ahead and make some tests right here. I basically have some voltages from 1 to 9 volts. I will assign about 2 amps. Let's go ahead and put I don't know, 4 amps for each individual step. Another annoying thing that I find is that every time I'm trying to modify one of these things right here, I will be prompted with some message, and it's not even in English. I don't know how to change it. It shows up trying to display some strange characters right here, and I don't really know how to change this, and I don't know what to do. There is no instruction on how to deal with this thing. Anyways, in order to go ahead and modify all these steps here, you have to put up with the fact that you will be prompted with this error over and over again. Phew. So now everything is set here. These time intervals that I assigned to each individual step, to each individual voltage step from 1 to 9, these are 2 seconds each. So basically I'm gonna have a 2-second step of 1 volt, and then another 2-second step of 2 volts, and so on and so forth until I reach 9 volts. And I want these steps to be repeated, and you select the number of cycles here, let's say 100 times, and I want these steps to begin at number 1 and to finish at number 9. So I'm gonna select the steps from 1 to 9 here and hit the start button, and as you can see here, the voltage steps are incrementing. So basically I'm obtaining voltage slope here, a rising slope. Okay, and then it goes all over again from 1 to 9. I can follow what's happening here on these diagrams to see what's happening with the current and with the voltage. And to make things more interesting, I have an oscilloscope here which we're gonna use, and this is a power resistor of 7 ohms. It's already loaded and it seems like the case it's vibrating. I don't know if this sound is gonna be annoying if you try to have this power supply always on your bench, or if you're gonna get used to it or something. But anyways, now in order to make this more fun, I'm gonna go ahead and modify all these time intervals here, how fast this power supply can be. So I actually set these time intervals right here to 0.1 seconds. That's 100 milliseconds. And my oscilloscope is showing something between 230 milliseconds and in some cases 300 milliseconds, depending on the voltage difference between the steps. So that means that this thing is not actually very fast. You can actually hear that there are some relays there and probably some circuitry that really works like some analog multiplexers or something like that. So that actually takes time before you manage to switch it from one value to another. But it's still a good thing because you can obtain pulses that are of very low frequency, or you can obtain some slow increase and decrease voltages to test some devices, and that can be really useful. Now, another annoying thing I was able to observe related to this power supply is that when I'm done with the computer here, and when I'm done with working with this software interface right now, and I actually want to switch to the manual operation here, there is no way of doing this. So I don't have any stop button for this application except for this on and off buttons. If I press the off button and then I try to close the app, and then I'm trying to operate it manually, it doesn't work because this thing is still connected to my computer. There is no way of disconnecting it. I even tried removing the USB cable and it still doesn't do anything. It seems like it's locking itself in some weird mode and there is no way of doing anything. The only way to operate it is to shut it down from the main switch, powering it on again, and then you can operate it manually. So this to me doesn't really make sense, and from my point of view, this is not how a remote power supply like this it's supposed to operate. It's clear to me that this is not some professional tool. This is something more a non-picky tool, if I could say so. Of course, another drawback would be the fact that if you keep it connected to the grid for a longer period of time, like 6 hours or 8 hours or so, this transformer inside of it heats up very much, and I don't know if this is such a good thing for long-term operation. If it's getting very warm inside, I think this will in a few years dry some capacitors inside or do something. How it looks inside, maybe it's a good time to take a look inside and see how it's looking like. For this, I'm going to disconnect the mains. As always, have fun with your electronics every day, and if you enjoyed my video here, don't forget to subscribe to my channel for more videos like this.